Okay, having a look at a grade 10 general maths homework sheet that my students are working on at the moment. So this one is due the 20th of October. For those in my class watching this, this is when this one's due. The first one is find the distance between the coordinates 2, 5 and 4, 8. So our distance formula is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. Now when we're looking at our coordinates, we've always got our x1, y1, x2, y2 there. So we're filling those in, and we can type this straight in the calculator. So we've got our y2 minus y1 is going to be 8 take 5 squared, and we've got 4 take 2. So I'll grab my calculator so you can see how I can type it straight in. So I'm going to do the square root sign, and then I'm going to put in what is there. So bracket, 8 take away 5, bracket, then squared. And then I've got plus 4 take away 2, bracket, squared. So I've just typed exactly what I've written there into my calculator. Then I'm pressing enter. Now you'll notice it comes up with the square root of 13. Then I can just press this white button with the arrows, which changes it to the decimal, which is 3.605, so I'll round that to 3.61. Finding our midpoint rule is our x1 plus x2 over 2, so we're basically averaging the x1 and x2 coordinates, and then y1 plus y2 over 2. So we have got our x1 and x2 is 2 plus 4 over 2, and then we've got 5 plus 8 over 2. So our 2 plus 4 is going to be 6, divided by 2 is 3, and our 5 plus 8 is 13, divided by 2 is going to be 6.5. And so our coordinate then for our midpoint is 3, 6.5. Here we've got find the equation of a horizontal line passing through 3, 5. Now we know a horizontal line is y equals something, and so looking at our coordinate, what's the y value there? It's 5. So our answer is y equals 5. When we've got the equation of a vertical line, that's going to be x equals something. So we need the x value from a coordinate that we know is passing through, and that's 2. When we've got the equation of a line parallel, that means it's going to have the same gradient as whatever line we're given. So we're given y equals negative 3x plus 5. So we know our gradient is going to be negative 3, just like that equation there. And it passes through 2, 5. So we'll write y equals mx plus c. Our y value is 5. Our m is negative 3. Our x is 2. And we've got a c. So we've got negative 6 plus c is 5. So our c is equal to 11. We then need to write the equation y is equal to negative 3x plus 11. If we've got a line perpendicular, we've got our first gradient is negative 2. Our new gradient is going to be negative 1 over the old gradient, which is negative 2. So it's going to be a half. So we're going to do the same thing as we did up here, but use this coordinate there and our new gradient of a half. So we've got y equals mx plus c. We're going to put in the y is 7. The m is a half times 4 plus c. Now a half times 4 is 2. 2 plus 5 is going to give me 7, so c is equal to 5. And then I'll rewrite my equation with those in there, a half x plus 5. Here we've got solving some simultaneous equations. We've got 3x plus 2y equals 21, and we know that y is equal to x minus 2. So where we see the y here, we're going to write x minus 2. This is a substitution one. So we've got 3x plus 2 outside of x minus 2 is equal to 21. When we expand that out, we get 2x take away 4. So we have 3x plus 2x is 5x, take 4 is equal to 21. We're going to add the 4, so we get 5x is equal to 25, so our x must be equal to 5. Then we're going to bring that back to here and say if x equals 5, y equals x take 2, so y must be 5 take 2, which is 3. So there's our x and y value. When we come to the one up the top of this page over here, we can see that we've got plus 2y and minus 2y, so we know we can use the elimination method. So that's where we add down those columns. So 3x plus x is 4x, 2y plus negative 2y is 0, and 9 plus negative 5 is 4. So if we have 4x equals 4, then x must be equal to 1. Then we can sub that into either of those equations there. I'm going to go with the x minus 2y, just because it has the least bits to work out. So I've got x minus 2y is equal to negative 5. If my x is 1, take 2y equals negative 5. I'll then take 1 from both sides and get negative 2y is equal to negative 6. So y must be equal to 3, because negative 6 divided by negative 2 is going to give me 3. I can then go back and check that in the original and go, okay, well, if I've got 3 times 1, I'll get 3. 2 times 3 is 6. 3 plus 6 is 9, so I know it's correct. Then I've got a set of 3 questions involving triangles. So my first one, so because these all have angles and sides, I know they're going to be my trig questions, as opposed to if they just had sides, I'd be using Pythagoras theorem. So I'm going to label my triangles first with A, O, and H. So here's my 50 degrees there, so I've got A, O, H. Here I've got 70 degrees, so I've got A, O, and H. And here I've got my theta there, so I've got A, O, and H. So I'm going to circle what I have 2 things on a side of. So I've got O and A, so I know this is going to be tan theta equals opposite over adjacent. Down here I've got O and H, so I know it's going to be sine theta equals opposite over hypotenuse. And here I've got A and H, so I know it's going to be cos theta equals adjacent over hypotenuse. When I put in my values over here, I know that I've got tan of 50 is equal to x over 5. So then I can just do 5 tan of 50 is equal to x. So x must be, and I'll grab my calculator, 5 tan 50 is 5.958, so I'll round that to 9.56. And my unit is meters. Here I've got sine theta equals opposite over hypotenuse. So I've got that sine of 70 is equal to 11 over x. Now we know if the x is on the bottom, we make them switch sides. X is equal to 11 over sine of 70. Grabbing the calculator, 11 divided by sine 70 is 11.7. Then my last one here, I've got my adjacent and hypotenuse. So I've got cos theta equals A over H. So I've got 7 over 11 is cos theta. So theta is going to be cos to the negative 1 of 7 over 11, which is going to equal 50.47. And that will be, or it's 50.78, so I'll round that to 50.48 degrees. Then I've got a worded question. So it says a person is standing 150 metres from the base of a tower. They see the top of the tower at an angle of elevation of 7 degrees. So we've got 150 metres along the ground, and we've got a tower, and we've got an angle of 7 degrees there. And we want to find the height of the tower. So labeling that, we've got A, O, and H. So it's going to be tan. So tan of theta is opposite over adjacent. Tan of 7 is going to be x over 150. So my x is going to be tan of 7 times 150, or 150 times tan of 7. And we get 18.417, which is 18.42, I'll round to, meters as the height of the tower. Here we've got a ship travels due south for 3 kilometres and then 5 kilometres at a bearing of 130. So I've got due south, 3 kilometres. Then we've got at a bearing of 130. So I'm going to put that around here. And that is for 5 kilometres. And we want to work out how far south it is from its starting point. So I can use a triangle here. Now I've got 130, which means this part of it must be 50 degrees because 130 and 50 add to 180. So I've now got an angle in the triangle and a hypotenuse, and I can find out this distance here, which is going to contribute to the distance south. So I've got AOH, so I've got cos theta is equal to adjacent over hypotenuse. Cos of 50 is going to equal my x over 5, and so 5 cos 50 is going to equal x, and that gives me 3.21 as my x. Now I've already gone 3 kilometers south, and then I've gone to 3.21, so the total south is going to be 3 plus 3.21, which is 6.21 kilometers. Okay, turning over to the second side of the sheet. We then have find the surface area of a cylinder with a height of 200 centimeters and a radius of 5 meters. So I'm going to change my centimeters straight to meters. And then I'm going to write my rule for surface area of a cylinder, which I know is 2 pi r squared plus 2 pi r h. So I've got 2 times pi times 2 squared plus 2 times pi times 2 times 5. So I'll work that out on my calculator. 2 times pi times 2 squared gives me 25.13. And then I've got 2 times pi times 2 times 5 is going to give me 62.83. And so when I add them together, I get 87.96. And that will be meters squared. The next one is proving that the two triangles below are congruent. So for starters, we can say we've got a common angle. So it's always easier to prove congruency if we've got some letters on here. So I'm going to put ABC, DEF. So I can say that angle B is equal to angle E. Then I can say that side AB is equal to side EF. Now I also know that BC is equal to AB, therefore BC is also equal to, and I also know that EF is equal to ED, therefore BC is equal to ED. So we've got two sides and an angle, so side, angle, side for our congruency rule. Therefore we can say that angle ABC is congruent to angle DEF. The next one says find the scale factor for the similar triangles. So if we've already been told they're similar, we just have to find the scale factor and then find x and y. So my scale factor is going to be by find the two sides that are corresponding and then do the bigger one divided by the smaller one. So my bottom number here corresponds to the bottom number on my other triangle. So my scale factor is going to be 4.5 over 3, which is just going to be 1.5. So then if I'm going from 5 to x, I'm going to times by 1.5. So x is going to equal 1.5 times the 5, which is 7.5. And then if I'm going back the other way, I need to divide. So y is going to equal 6 divided by 1.5. Which gives me 4. And that is in meters. The next one, I want to prove that they are similar triangles. So again, like with the one proving the congruent, it's easier if there's some letters on there. So I'm going to pop some letters on. So I can say that angle B is equal to angle E. I can then check scale factors of the sides. So to go from 3 to 6, I've multiplied by 2. And to go from 4 to 8, I've multiplied by 2. So my scale factor equals 2 for the AB to DE and also for BC to EF. So therefore it's side, angle, side. Therefore triangle ABC is congruent to triangle DEF. Expanding. So this first one is our smiley face. So I can draw in those lines and I get M times M plus 3 times negative 3 plus 3 times m, take 3 times m. So I get m squared take 9 plus 3m take 3m. So I get m squared take 9. Now, you may have seen that and recognized that as difference of two squares, which means you would have been able to go straight to m squared take 3 squared equals m squared take 9. Obviously, we want you to do it the shorter way. So if you can recognize that pattern, that's obviously going to make it quicker for you. When you see a plus 4 all squared, you know that's a plus 4, which is another one of our patterns. It's a perfect square, so it's going to be a squared for the first part. On the end, we're going to have 4 squared, and in the middle, we're going to have 2 lots of a times 4. So we get a squared plus 8a plus 16. Okay, up the top here, we're expanding our 2 sets of brackets using our smiley face. We don't have any patterns for this one. So we have a times a plus 3 times 2 plus 3 times a for the nose plus a times 2 for the mouth. So we get a squared plus 6 plus 3a plus 2a. So we get a squared plus 5a plus 6. Here we've got our 2m times m plus 3 times negative 4 plus 3 times m, take 2m times 4. So I've put the take there because of the takeaway there. So we've got 2m times m is 2m squared, 3 times negative 4 is minus 12, plus 3m take 8m. So we get 2m squared, 3m take 8m is minus 5m, take away 12. Now we're doing some factorising. So for our factorising ones, we're writing down our a equals, b equals, c equals. So our a equals 1, b equals 7, c equals 12. So we're looking for two numbers that multiply to give 12, but add to give 7. Now we know that 3 and 4 multiply to give 12, and 3 plus 4 equals 7. So we can write x plus 3 and x plus 4. Here we've got m squared plus 8m plus 16. Now you might recognise that as a perfect square and be able to go straight to that. Otherwise, we're writing down our a equals 1, b equals 8, c equals 16. So our ac equals 16 and our b equals 8. Two numbers that will multiply to give 16 but add to give 8 are 4 and 4. So then we would write m plus 4, and then we can change that to m plus 4 all squared. The last one in our factorising is a difference of two squares because we've got a squared take away 7 squared, and we know that the pattern for that is a plus 7, a take 7. Last one on this homework sheet, we're factorising and then solving. So a, b, c, a equals 1, b equals minus 7, c equals 12. So we're looking for two numbers that will multiply to give 12 but add to give negative 7. So we use negative 3 and negative 4. So when we put that in the brackets, we have y take 3 and y take 4 equals 0. That's when we can then use our null factor law and say that either y take 3 equals 0, which means y is equal to 3, or y take 4 is equal to 0, which would mean y is equal to 4. And that's the end of the homework sheet.